12th century, the people of the Ore Mountains found treasure. Silver lay deep in the earth. But this was accompanied by a curse for the miners. Water poured into the tunnels and shafts, preventing them from reaching it. A clever plan turned the curse into a blessing. Silver was first discovered in Freiberg in 1168. Many miners swarmed to the city, hoping to find their fortune. The work was hard. To extract the ore, they had to draw water from the shaft, what the miners called raising water. The machines were operated by hand, a process which cost power and time. After quarrying the ore near the surface, the miners continued digging deeper, but they only came upon more water. In the 16th century, clever engineers invented new machines, pumps to carry the water away. They were powered by man-made wheels moved by water from above-ground streams. The new machines made mining profitable once more, and the miners could continue removing silver ore from the Freiberg earth. The use of water-powered machines became increasingly popular in other areas of mining as well. The energy from water was also used for stamp mills and forges, for drainage, transporting miners and stone, as well as ventilating the galleries and shafts deep below the earth. This caused an ever-increasing demand on water, but the reserves of the nearby streams were almost exhausted. In 1558, an order of the Electoral Prince initiated construction of a man-made water network. Water was to be collected above and below ground and directed to the machines in the mining area. The foundation for the Revierwasserlaufanstalt water storage network in Freiberg was set. The silver it helped to mine also brought the electors much money, and Dresden its splendor. The underground water supply was carried in so-called water galleries. Today, they are managed by employees of the State Reservoir Administration. The rock of the 400-year-old Müdesdorfer water gallery is still in amazingly good condition. It is 1,827 meters long. Today, the Freiberg water storage network oversees a water gallery system 23 kilometers long. It is especially important for traversing hills. The water runs continuously downhill between the Rauschenbach Dam and Freiberg. The water network has an overall difference in elevation of 150 meters over a distance of approximately 60 kilometers. 53 kilometers of man-made trenches run along the surface. A covering prevents the water from evaporating. It also protects from vegetative growth, freezing in the winter, and from buildup of foliage and animal waste. The water flow of the man-made trenches is regulated in the sluice house. This is where the desired flow is introduced from lakes and streams, such as here from the Zettauer Dorfbach, into the water storage network. The water from the man-made trenches flows into lakes. There are 10 of these in the water storage network with an overall holding capacity of 5.5 million cubic meters, an important water reservoir throughout the changing seasons. The flow rate from a lake can be controlled in a valve chamber. In times when water is abundant, such as spring, the water is stored. During dry periods, this reservoir is made available. At the end of the 19th century, the price of silver on the world market fell. More and more mines had to be closed. In 1913, the Freiberg mines were completely shut down. The Freiberg water storage network, which was valued in the millions, no longer served any function. But thanks to the vision of forward-thinking engineers, it still exists today. Since 1914, the underground hydroelectric power station in the Three Brothers Shaft supplied clean energy for Freiberg, powered by water from the water storage network. A masterpiece of engineering technology. Water from the reservoir was carried to the turbines of the upper substation through a penstock. An incline of 124 meters was used. After generating power, the water fell into an underground reservoir. Mine water from the mining area flowed into this. The water could climb up to the Moritz Gallery, allowing 1.5 million cubic meters to be stored. Then the water powered the lower substation turbines. Operation of the underground hydroelectric power station ceased in 1972. But the following decade saw ever more people make their way underground. Mining enthusiasts who wanted to marvel at the old machinery. The turbines in the cavern of the lower substation are still in good condition. This archive footage from 1997 is the last evidence of how it once looked. During the flood of 2002, the Rotschenberg Gallery broke. Water poured into the cavern chambers and destroyed the technical equipment. Today, an above-ground exhibit is dedicated to the sophisticated power engineering. The control room of the power station from 1914 is still in its original condition. The Three Brothers Shafts Society has lovingly adopted the old equipment. The mining enthusiasts are happy to share with visitors their knowledge of the Freiberg water storage network's origins, the machinery of the underground hydroelectric power station, and the value of sustainable water use. The Freiberg water storage network serves an important role today as well. Every day, 10 employees of the State Reservoir Administration maintain the 500-year-old waterway system of artificial lakes, water galleries, man-made trenches, and pipelines. The water network is an important basis for the industrial and drinking water supply in Freiberg and its surroundings. The most modern technology is used to monitor the quality of the drinking water.
1,6.
Ach, Temperatur.
Die ist 14,5 Kegel. Ja. Fahrwerksüberwachung ist in Ordnung.
The valve chamber is located in the front of the dam of the upper Großhartmannsdorfer Lake. It is the headquarters, the heart of the dam. In 2000, the 400-year-old machinery was updated with state-of-the-art technology. Valves precisely regulate the water flow and the amount, which reaches customers as far as Dresden. Up to 240 liters of water flow through the pipes each second. The abundant water supply in the Freiberg area, with its high quality and low price, also led to the numerous industrial zones that sprung up on the outskirts of Freiberg. The silicon and solar industry has found an important production location here. Thousands of wafers are cleaned each day with water from the water storage network. The Freiberg water storage network is also a dependable partner for leather production. The company Wert Leder dyes and finishes products for Rolls-Royce and BMW. 30 to 40 cubic meters per day are needed for this. The water storage network also pays heed to nature conservation. Rare fauna and flora have settled near the water and are protected. Tourism is just as important. People from the surrounding region can use Erzengler Lake, which supplies industrial water, to go for a swim. The Freiberg water storage network, with its 500 years, was and remains a lifeline for Freiberg, an industrial monument bridging the past and the future.